Okay, this is the worksheet for section 6.3 that we did for 6.3 day 3 and the frequently asked questions for this one. I thought I'd just pick a couple out of each one of these groups here for us to look at. And number 4 has add or subtract if possible. And what we have to check is the index and the radicand exactly the same? And both of these are going to be cubed roots of xy, so that means we can actually do the subtraction. So if we have 14 cubed roots of xy and we subtract 3 cubed roots of xy, we will have 11 cubed roots of xy. And so it really is all about, did you check to make sure that the index and the radicand were the same before you did your subtraction? Then we get to number 5, and in number 5 we have a cubed root of x and a cubed root of y. And those are not the same radicands. They do have the same index. The index is a 3, but they're not the same radicands, so we can't do that. And we would just write can't be simplified. And I saw some of you writing can't do on your worksheets, and that's exactly right. So can't be simplified, cannot be simplified. All right, the smartboard was having a couple of hiccups. So let's look at number 13. Number 13 has 2 fourth roots of 48 plus 3 fourth roots of 243. And it's always a good idea to start with the smaller of your roots. So I'm looking at 48. And I go to my power chart, and I see the fourth root. I could try 16, and sure enough, 16 does divide evenly into 48. So 2 fourth roots of 16 times the fourth root of 3 plus 3, and then I think about 243, and I realize the only way I can do this problem is if 3 goes into this nice and evenly, and I get 81. So now I go back to my power chart and I see, oh, look at that, 81. Fourth root of 81 is going to go nicely into my 243. So fourth root of 81 and fourth root of 3. So now I have fourth root of 16 is 2. Fourth roots of 3 plus 3 times the fourth root of 81 is 3. Fourth roots of 3, and then when things are right next to each other in algebra, that means we multiply. So we'll have 4 fourth roots of 3 plus 9 fourth roots of 3 for a grand total of 13 fourth roots of 3 for number 13. Number 15, looking at cubed roots, we have the cubed root of 250 minus the cubed root of 54. So you're looking at cubed roots, you might want to go after the smaller one first and say 54. All right, cubed roots, 54 would land there. Hey, 27 divides nicely into 54. So we get the cubed root of 27 and the cubed root of 2. Well, if we're going to be able to do the addition on these two, the cubed root of 2 has to be in the 250. And it is, and it gives you the cubed root of 125, which, it just so happens, is one of our perfect cubed roots. So let's see what this looks like split up. This will be 5 cubed roots of 2 minus 3 cubed roots of 2 using our power chart backwards, and that will give us 2 cubed roots of 2 for number 15. From the next group, number 20, and these just simply say multiply, but you've got a lot to keep track of. So first times first here is 2. Again, we're going to use FOIL whenever we have two binomials. And then we do outside times outside, which is -1 square root of 10. Inside times inside plus 8 square roots of 10, because we take the integer portion times the integer portion. Radicals times radicals. Last times last, -4 square roots of 100, because the square root of 10 times the square root of 10 is the square root of 100. And then we have our two aha moments where we notice we can put our two middle terms together, and -1 square root of 10 plus 8 square roots of 10 is 7 square roots of 10. And then we notice, hey, the square root of 100 is 10. So this will be 2 plus 7 square roots of 10 minus 40. And so for number 20, we end up with negative 38 plus 7 square roots of 10. Because again, to add, they must be like radicals. So we're putting the integers together to add those, and then we have the radicals, which were the square root of 10. Number 24. Now that the smartboard seems to be behaving a little bit. Let me see if I can get 24 to fit up here. And this will be 2 square roots of 3 minus 3 square roots of 2. And since it says squared and exponents go to the closest thing to their left, the closest thing to the left here is the parentheses. So that means we have to write down everything in both parentheses twice in order to multiply these together. Now we do first times first. 2 times 2 is 4. The square root of 3 times the square root of 3 is the square root of 9. Then we do outside times outside minus 6 square roots of 6, because 2 times 3 is 6, and the square root of 3 times the square root of 2 is the square root of 6. Inside times inside, we'll have minus 6, because negative 3 times 2 is negative 6, and square root of 2 times the square root of 3 is the square root of 6. Last times last, a negative times a negative is a positive. 3 times 3 is 9, and the square root of 2 times the square root of 2 is the square root of 4. So again, a couple light bulb moments here. We know that the square root of 9 is 3. We know that a negative 6 square roots of 6 minus 6 more square roots of 6 is minus 12 square roots of 6, which fits the pattern of a binomial squared, plus 9 times 2. And then we have 12 minus 12 square roots of 6 plus 18, and 12 plus 18 is 30 minus 12 square roots of 6. So that is number 24. From the next grouping, we have 30 and 31. Again, it's along the same lines of what we were just doing, except these follow that sum and difference pattern because they are conjugates of each other. So notice that the first term and the second term are exactly the same, but one has a plus and one has a minus. And again, that's the sum and difference pattern. So now, all I have to do for these, I don't have to do all of FOIL. I can just do FOOL, first times first and last times last. So first times first is 25 square roots of 9. Last times last is minus the square root of 4. Well, we know the square root of 9 is 3, and we know the square root of 4 is 2. So 75 minus 2, which is 73 for number 30. For number 31, first times first will give us 9 square roots of 4. Last times last minus 4 square roots of 9. 2 times 2 is 4, and square root of 3 times the square root of 3 is the square root of 9. So that will be 9 times 2 minus 4 times 3, and that is 18 minus 12, which is 6. So number 31 is 6. Next grouping, rationalize the denominators. So in 35, we have 2 plus the square root of 14, and then on the bottom, the square root of 7 plus the square root of 2. And the first thing I check is whether or not any of this can be simplified. But there aren't any perfect squares that will go into 14, 7, or 2 nice and evenly. So what I have to do is multiply by the conjugate, which means I have to have the square root of 7 and the square root of 2 on the bottom. But if that's a plus, then the conjugate has a minus. And whatever we do to the bottom, the denominator, we have to do to the top, the numerator. And now I want to make sure my denominator works. So I'm going to do that part first. Square root of 7 times square root of 7 is square root of 49. And then I think, well, these are conjugates. This is a sum and difference pattern. I don't have to do the O and the I in FOIL. I just have to do first times first and last times last. So square root of 49 is 7, and square root of 4 is 2. So we're going to get something over 5, which is great. That makes sure that we're on the right track. All right, now our numerator. 2 times the square root of 7 is 2 square roots of 7. 2 times negative square root of 2 is minus 2 square roots of 2. Square root of 14 times square root of 7, I'll do the math over here for us. We get the square root of 98. And then we have the square root of 14 times negative square root of 2, which will be a negative square root of 28. All right, now let's keep going. So we notice that we don't have any like terms in the top yet, but we started thinking about these two numbers right here, and we can simplify those. So this will give us 2 square roots of 7 minus 2 square roots of 2 plus 49 goes into 98 twice, plus 49 square roots of 2 minus the square root of 4 times the square root of 7. And I realize I'm not going to have enough room here for my over 5, but at least we know that over 5 is going to be a good thing. All right, so that would be 2 square roots of 7 minus 2 square roots of 2 plus 7 square roots of 2 minus 2 square roots of 7. And now we have like terms. So 2 square roots of 7 minus 2 square roots of 7, that's gone. That's helpful. And then negative 2 square roots of 2 plus 7 square roots of 2 is 5 square roots of 2 all over our little 5. And the 5's will cancel. And we'll get the square root of 2 as our answer for number 35. 36. I'll go ahead and write below this one. That is 2 plus the cubed root of x over the cubed root of x. And for this one, all we have to do is figure out how to rationalize the cubed root of x to the first. Well, that means we don't have to do the conjugate. We just need 2 more x's. Because then our denominator will be the cubed root of x to the third, which is just x. So that's going to work out very nicely. Now let's go back and see what we have across the top. We'll have 2 cubed roots of x squared, because we have to distribute our cubed root of x squared. And then we'll have the cubed root plus the cubed root of x to the third. Well, there's another nice x in there. So we'll get x plus 2 cubed roots of x squared all over x. We cannot factor an x out of the numerator, so we just have to leave that as it is. 40 and 42. These say simplify and don't worry about absolute value. We have 4 cubed roots of 81 plus 2 cubed roots of 72 minus 3 cubed roots of 24. And like we said in class, go after that smaller one first. So here in the back, hopefully you'll start thinking about some of your cubed roots again, and you'll remember, let's see, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. That's already too big. So we try our 8, and that goes in 3 times. Now, if that's the case, this is what should be in all 3 of these terms if we're supposed to be able to go ahead and add and subtract all of these. So in the front, I think, well, what would happen if I divided 81 by 3? And I would get 27, which happens to be a perfect cube on our chart. What would happen if we take 72 and divide it by 3? Well, let's just see. That comes out nicely to 24. But 24 is not a perfect cube. So it turns out we're going to be able to add the front term together and the back term together, but not the middle term. So I start thinking cubed root of 72, and I realize, well, that's cubed root of 8 and cubed root of 9. So I can still simplify it, I just can't add it and subtract it with the other like terms. So now we have a 4, and the cubed root of 27 is a 3, cubed roots of 3. And the cubed root of 8 is a 2, cubed roots of 9, minus 3, and we have the cubed root of 8 is a 2, and the cubed root of 3. So this will give us 12 cubed roots of 3 plus 4 cubed roots of 9 minus 6 cubed roots of 3. So again, there's 2 terms we can put together, but there's another one. So 12 cubed roots of 3 minus 6 cubed roots of 3 is 6 cubed roots of 3 plus 4 cubed roots of 9. And that's the best we can do with number 40, because again, not all 3 terms were like terms. Then number 42 has 6 square roots of 45 y squared plus 4 square roots of 20 y squared. So first thing we do, let's separate those numbers from the variable parts, because remember, numbers behave differently than variables do. And we find, hey, that's going to work out really nice for our y's. The square root of y squared is y. And then we have to simplify the square root of 45, and that, of course, is the square root of 9 times the square root of 5, and we have our little y. And for 20, the square root of 4 and the square root of 5, y. And let's go back and find the square root of 9 is 3, and the square root of 4 is 2. So this will give us 18 y square roots of 5 plus 8y square roots of 5. And 18y plus 8y is 26y square roots of 5. And again, they said not to worry, assume all variables are positive. So I think that should be enough for worksheet 6.3, day 3.